Today my topic will be iron deficiency anemia, the laboratory diagnosis, including the hemoglobin estimation, peripheral blood smear, serum iron, TIBC, and creatine level. So first of all, let's go to the basics and what do we mean by iron? So iron is a metallic element that plays a key role in the oxygen transport and circular respiration. So iron are stored as follows. Like most of the irons are stored in the hemoglobin for the oxygen transportation, and 20 to 25% are stored in a storage form as in ferritin and hemoglobin, and 10% are stored in the myoglobin and enzymes which in the muscle, and less than 1% of the serum iron are circulating in the circulate in the body. So what do you mean by the iron deficiency anemia? So iron deficiency anemia is a condition in which the body lacks sufficient iron to produce adequate amount of hemoglobin that reduces the oxygen carrying capacity. And hemoglobin synthesis decreases as the iron stores are inadequate, leading to the formation of smaller, paler, and red cells, which produce less red blood cells, and that decrease the oxygen level in the body. So this is the lab diagnosis of the iron deficiency anemia. These are the hematological screening and morphological tests like the HB test and the peripheral blood flow. And here is the biochemical iron studies like the serum iron, TIBC, and the serum ferritin. So first of all, let's go to hemoglobin estimation. So hemoglobin estimation is the primary screening test for the anemia. And in case of the iron deficiency anemia, the hemoglobin level decreases gradually as the iron stored is depleted and the hemoglobin synthesis is became impaired. And what we have to remember is that this hemoglobin estimation is not it doesn't identify the cause of anemia. It just provides the critical quantitative evidence for the severity and guidelines for the laboratories for further investigation. So the normal hemoglobin level is for men 13 to 17 gram per deciliter, and for women it's 12 to 15 gram per deciliter. But in case in iron deficiency anemia, the hemoglobin level is decreased. Therefore, the female hemoglobin level will be 12 less than 12 gram per deciliter, whereas the male would be less than 13 gram per deciliter. So let's go to peripheral blood smear. So in peripheral blood smear, it provides the qualitative morphological evidence that support and confirm the diagnosis of IDA. And peripheral blood smear reveals the underlying pathophysiological defects of the erythropoiesis. So as we have already said that the hemoglobin level, as the hemoglobin level decreases, the red cells become pale, smaller, and their shapes and size can be varied. So here are the peripheral observations of the IDA. So in red blood cells, microcytosis and hypochromia, and anesthetocytosis and polymyelinocytosis look like target cells. And white blood cells are usually normal or can be slightly increased. And in case of platelets, it increases and it often enlarges the platelets. And in case of RDW, the red blood cells get increased. So let's go to serum iron. So serum iron is the amount of iron that present in the blood serum that bound to the transferrin. So serum iron is a deadly iron that promotes the production of free radical formations, and 1% of it is stored in the circulating iron. So if the free radicals are present, it participates with the chemical reaction, which increase the oxidative stress, and the lipid peroxidation error is cause cell damage. So here is the estimation of the principal estimation of serum iron. First, the iron is transferred to the is released. the transferrin and the serum iron. Usually the iron is usually present as ferric iron, which is then reduced to ferrous iron, which is the safe form of iron. And the safe iron reacts with the chromogen, and this chromogen reaction produces a color complex, which is a purple color complex, which is detected again by the calorimeter or spectrophotometers. So in iron, which results in the less iron reaction, it reaches circulation and transferrin remains underloaded and serum iron falls down. So as we've already said, these are the same thing that we said just on the previous slide. And now total iron binding capacity, TIBC. So TIBC measures the maximum amount of iron that serum transferrin can bind. It indirectly reflects the concentration of the transferrin. And it does not measure the iron, but it measures the capacity to bind the iron. So estimation of TIBC, first the serum gets treated with the excess iron, and the unbound iron is removed, and the iron bounded to the transferrin is measured, and then after measuring it, we report the total iron binding capacity. So the normal value for the TIBC is 250 to 270 microgram per deciliter, and in case of IDA, the TIBC level will increase, which is more than 400 microgram per deciliter. So why does the TIBC get increased? So the TIBC get increased because the binding capacity increased and the liver production for the transferrin is increased as the production of the erythropoiesis is increased. And the body attempts to capture every available iron atom and the liver produce more transferrin. So let's go to serum ferritin. So serum ferritin is a protein that stores iron inside the cell. And this serum ferritin is the non-toxic form of iron. And the ferritin reflects a small amount of ferritin leads into the serum, that is the total body iron stored. So ferritin falls first before the development of anemia. So the first and primary test that we will be doing is the serum ferritin test, because usually the serum ferritin level drops before the development of anemia. So serum ferritin is said to be the best test for the iron estimation. So the normal value for the serum ferritin is for adult male, 50 to 300
nanograms,
nanogram per deciliter, and female will be 15 to
picograms. Yeah. Okay.
And in case of IDA, the serum ferritin will
50.
less than 15 nanogram per deciliter. So serum ferritin storage, it usually stores in the liver and produced by this serum iron reflects the amount of iron stored in the body and make it the most reliable detector for the iron to store. So the iron is stored as ferric hydroxide inside the ferritin shell, and it controls the iron regulatory protein and hepcidin. For the estimation of serum ferritin, we usually use the immunoassay techniques like the ELISA. So ELISA can be luminescent immunoassay and automated immunoassay analysis. So we use this antibody antigen reaction because this serum ferritin, this process is best for the production of more accurate results for the serum ferritin ions. So for the test of the serum ferritin, first the sample is collected through the file, and through the immunoassay test, the iron transferrin gets saturated, and then which we then measured, and these are the results that we can get. The normal values are given here, and in case of increased serum ferritin, it can be due to hemochromatosis, inflammation, disease, or iron overload. And in case of iron deficiency in decreased ferritin, it can be due to iron deficiency anemia, which includes pregnancy, chronic blood loss, and protein deficiency. The combination diagnosis to conclude the tests that we have performed. In serum iron, the IDA decreased, which reduces circulating iron, and in TIBC, TIBC it can increase and increase transferrin synthesis. And in ferritin, the level decreases, and it result in the depleted iron store. Transfer saturation also decreased, and it reduced the iron availability. So to conclude today's seminar, the understanding of the physiological meaning, relatory mechanism, and the interrelationship is far more important than memorizing the values. And for medical laboratory technologies, mastery of this concept ensures an accurate diagnosis, proper differentiation of the anemias, and a meaningful contribution to the patient care.
Yeah. Well done. Very good. Yes. So, very nice, Feli. Of course, it's fantastic. Okay. Go back. Now, back. Very good. Go back one more slide. See, can you interpret these things? Why increased ferritin? Why these conditions associated with increased ferritin? Can you explain? Why hemochromatosis leads to increased ferritin? Why iron load leads to increased ferritin? Yes. Can you try to brainstorm yourself?
As the production of the iron increase, the ferritin level, because iron intakes are increased, and which increase the ferritin level.
Very good.
Due to overload of
Yes, due to increased, when you said iron increase, that means iron overload due to some hemolysis. So, since there is extra iron, so extra ferritin was increased. That is why ferritin levels increased. Then you said ferritin saturation somewhere. What is, okay, that we'll see later. And now tell me any one of this. Why in pregnancy ferritin levels decreased?
Because during the pregnancy, it's not under the body produce. Like it's not absorb, or the collection of the iron gets increased, because the baby also depends on the mother very much. So if the iron intake or the mother treatment for the mother care, the patient, the mother cannot be able to compensate
Very good.
iron in her body. So
Very good. Yes. Well done. She knows what she prepared. Well done, Feli. Yes. Everyone. Good job. Good job.